We are going to move today to talking more about assessment, but Lita had asked me to start off by looking back at what we did yesterday and seeing common themes, common ideas that were discussed across the multiple groups. And I had a couple of observations, and I'd like to make a couple of encouragements. So recommendations for thinking about your projects in the future and perhaps staying in touch with other people who are building networks. I think of my observations, and I saw the grant proposals before you were funded, so I knew what was going to be awarded, and I knew what people were doing. But what I was surprised by, and when we heard about it and talked about it, was how many of you did multiple topics. Many people did all of the topics that we addressed in the original MENA workshop. Rather than picking one theme and doing that, you were all very ambitious. And not only were you ambitious, you were successful at it. Because from what everyone said about their evaluations, many of the topics were things that the students or even your colleagues were unfamiliar with. And were unfamiliar in a way that surprised you, perhaps. I heard, and I don't know if this was true for everybody, but looking at my notes, that dual-use research and the possible harms that can come from science was an unusual concept for many people. And I think that as we go into the future of science, where there are always questions about how the science can be used, how the technologies can be used, that's a fundamental question for most people going into science. We started with physicists thinking about atomic weapons and atomic energy, both of which, good and bad, came from basic science, basic knowledge about the atom. In biology, life sciences, we see not only the potential for great understanding of infectious disease, but the ways in which infectious disease can be used to harm people. And that's not even the fact that many times the knowledge has unanticipated consequences, even if people aren't trying to use the science for harm. Things can happen that we don't anticipate. Personally, I think it's much more likely that unanticipated harm occurs instead of intentional harm occurs. But students especially don't believe that their mistakes are going to hurt anybody. And so I think it's particularly important to focus on that as a component of both ethical practice and responsible science, to think about the potential for harm from your work. And that's a topic that I think will never go away. So the fact that your students were surprised by it, and your colleagues maybe didn't talk about it in their education either, means that that's always going to be a fruitful area to talk. Aside from biosafety, biosecurity, the measures, we don't have many skills and techniques. We don't teach concrete ways to avoid harm. Chemical weapons, chemical use, the chemical security and safety. But we don't talk much about how to think through your work before you do it, which is something that goes across all disciplines. And for which, in my experience, there isn't very much material to teach with. It ends up being about personal conscience and a social network of scientists who talk about things that concern them. So I would ask, do any of you know about either internet sites or social sites where your trainees could see other scientists talking about the complications of their work? because today with the internet, students are accustomed to being in chat rooms and blogs. Less chat rooms these days than other kind of postings. Because that would be a way that you could pay attention to the social responsibilities of scientists. There are scientists who work, again, with biological and chemical weapons, but with the broader questions of just thinking about unintended consequences. We don't see that written very much. Has anybody seen that? You've done in biosecurity. Have you seen the more informal discussion?
In security, they have some materials from Bradford University, but about chemical, when I need to prepare my lecture about the use of chemical, they have
Nothing. And beyond,
only they have one book from developed by NASA. No materials about use chemical and about how Austin about chemical use and use of
thinking,
Yes, I attended different occasions by safety workshops, and I think next month I will going also to attend another risk management course.
a risk, biorisk.
Teaching
And I think when we teach students skills, they need to have the attitude and the understanding also.
Also, I
And that's
think-
harder.
Yes, I think also that I believe that wherever we teach biology or molecular biology and these things, there must be course for teaching their biosafety and biosecurity for students, because this is a very concern.
And when we look at cases where there's been accidental release, it's often the student who's made, and I think last year we had a skit where the student spilled something. And that's what happens in real life. Alistair?
When we prepared the material on multiple uses of chemicals, we deliberately went away from dual use because we felt that dual use was a term that was determined by the military.
It
And
is.
all chemicals have multiple uses. So the material on the web is about lots of different case studies and interactive, but it does cover a lot of aspects of misuse. But in the chemical industry, there's a program called Responsible Care. It was a Canadian initiative. There are many different companies who signed up to this, and this is about how you manage your chemicals, reduce emissions, do things more efficiently, use less energy,
Help society.
treat your workers. Well, it's about the chemical
Treat your
industry trying to get its act together because of accidents like Bhopal, Severso, Flixborough, and it's an initiative that lots of chemical companies are trying to sort of sign up to.
Yeah, I just how can you use it to find the materials about chemical and chemical the use of chemical? Because when we write the use of chemical, we have the materials.
No, but I mean, when you think of a chemical, any chemical, salt has a multiplicity of uses. Chlorine can be used to, disinfect water. It's a chemical that you attach to others to enable you to attach different chemicals. And so every chemical has many, many uses. So we felt that if we talk about dual use, we're confined by the way the military and the security services talk about chemicals. And we wanted to get away from that because really the OPCW, although it is about chemical weapons and anything that uses the toxic properties of chemicals is a chemical weapon. But if it's not intentionally to harm someone, everything is permitted. So the OPCW is about, if you like, promoting chemistry as much
Promoting
as
chemistry and safe use of chemistry.
Absolutely. And of course, all chemists, when you were talking about things, we're all trained to do risk assessment. So before you do your experiments, you have to
Think
think about the
about
risks.
what's going to be involved.
But it's more from the safety.
I think American Biological Association has got a website where there's a lot there.
Yeah, absolutely.
And this whole question of what it means to do responsible science comes back to what does it mean for the scientist to think of himself or herself as responsible. That's harder to teach students. Some students are automatically interested in being good people as well as being good professionals. Others just want to pass the exam.
Exactly.
Because they are, I mean, to be
They're young.
To be a research or there are different type of people doing research. Some they
Also
do it
true.
for curiosity, and some they do it for just happen to be there. So they do it. Then they will not be able to recognize what they are doing. But if you are doing it with curiosity, you know exactly what
Mhm.
what's going beyond or behind. You think always perspective. There must be a perspective. But if it is just a routine, research for maybe which is not well planned, that might be misused.
And this is one of the other challenges that everyone in the room mentioned. Not just challenge, but took different approaches. How advanced in their degree
Yeah.
should the students be when they study this material? This is something everyone said, and most of you had people who were a mix of ages. Some faculty, some doctoral students, some master's students,
Yeah.
and a couple people tried teaching undergraduates, which I think is very admirable, but a little bit different because they haven't had the science yet to understand the bigger picture.
Yeah.
And the question of when it is that we teach about responsible science has two kinds of answers. It has the answer about when in the curriculum we teach, and then it has the answer, how can we teach it all the time? How do we teach it in ways that it's in every part of the science education?
And we need to translate this material to another language.
Absolutely. And that you actually anticipated that I'm going to say something in a minute, I hope to lead to the translation that are going to be done in Morocco next 2 weeks?
Next weekend,
Next weekend.
in 5 days.
5 days from now, there will be materials in Arabic. But to think about when do you teach how to be a good scientist?
It's very difficult.
So let me ask that in English that I hope will be understandable because it's a play on the words. When do you not teach how to be a good scientist when you're teaching science? They should always be together. And that's very hard. When you're trying to teach students the piece-by-piece elements of the knowledge at the same time as how to use the knowledge responsibly. Students are more interested again in passing the test and not thinking about what they're going to be like as adults, practicing as responsible professionals. Because often they can't see that far down the road. They can only see what's on the test or what the homework is for next time. But one of the things that has been important in the American discussion is this idea that there's different kinds of teaching appropriate at different stages. When Lita and I first met, she was a doctoral student and I was a young faculty member in a course that was required for all graduating doctoral students. At some point, you had to have it in your doctoral education. That course started out, it was the first required course in the United States, not by me, but by my mentor, who had started it as a very small course of a few interested students. They started with 7 MD, PhD students, so people who were going to be clinical scholars. And they started at lunch with a conversation about topics that the students were interested in. And then it grew. And then there was a cheating episode, a scandal at the university where people cheated. And the dean said, everybody's going to take that course. And he paid for lunch for students to come and take the course at lunch. And then it became required. The faculty voted and said, everyone's going to take that class before they graduate. And so we went from having 8, 9 students to having 140 students overnight. Was that a success? It was a success, but it changed the nature of the course. So what I heard everybody saying yesterday was they had small groups that were interested and bigger groups that seemed interested. The time limits that you had because of the end of the term may have made your groups smaller than they would have been otherwise. Sometimes starting small lets you have more control at the beginning. Because if it's suddenly a class for everybody, then it's not special anymore. And you may not have the time to teach it the way you want to teach it. So starting small can be good. Our class, with 140 people, we had one person who did a presentation at the beginning for half the class, and then we had case discussion with 6 or 7 faculty facilitators in different groups. And it was a problem because not everybody in each of the groups was the same level of preparation, and some people talked all the time. And we had a number of Chinese students who didn't speak very well. Their English wasn't very good, and they didn't say anything. So starting small can be good. Getting big can be great if you're ready for it. But then the question, how do you work with all the other faculty in your university who are also being role models for teaching? Several of you, I was very impressed, had colleagues who weren't part of this program who also came in and taught with you. How did you get them to do that? We didn't ask about that yesterday. How did you convince your colleagues this was worth doing? Did they owe you something and you just brought them?
في حد اشتغل معاكم؟ ما حضرش كيف اشتغل؟
Of course.
They were excited? Or they just did because you were their friend?
For our course, me and Dr. Abdelkader, one of the reasons to select Libyan emergency group because the leader or the president of that association attended ethical course with me in 2009. So he was interested to create some course, and also he asked me always, Ali, we'd like to do small course for clinical ethics. So when he heard some about the responsible side, he was very, and he tried to help us. Unfortunately, the second day he had a car accident. He's safe now, but because we decided to give him small group to share with us, because I would like to work like a resonant probe from this group, this group.
Mm-hmm.
But maybe this could be one of the reasons that share knowledge, or I believe that the people who has previous experience with the ethics or something like that can be
Someone who's been either outside the country or outside your university who's done it someplace else.
yeah.
I think that there's always somebody else who's interested. You're never completely alone. The trick is to find them.
Yeah, I think there's a personality trait here. And the personality plays a very important
It
part.
does.
Some people get involved in this because their personality is quite suitable. They are concerned, the altruistic kind of personality, and but some others, they really don't care. Whatever you do, they stay away.
This actually, and I laughed when Sarah, you said that your dean, or you had a senior faculty member who said he didn't want it. We don't need that.
On Japan,
Yes, that just, we don't need that. And there are lots of people who think, number one, you should have learned all the ethics you need to know by the time you're 5. Everybody should know not to cheat and not to steal and not to lie. What else is there? Well, what else there is all the professional education. All of what it means to be a physicist or a biologist or a chemist or a microbiologist. What does it mean to be part of that professional group? Which means that people who think it's all about the ethics of being a good person are missing the professional education part. You all also had multidisciplinary groups. What can a biologist learn from a chemist? Several of you had, you said, good discussions, interdisciplinary discussions, because people said, we do it this way, and others said, well, we don't do that, we do this. And then you had raised the question in a much more active learning style. Why? Why do physicists, for example, put 500 people on a paper as authors? Why? Whereas biologists might say, okay, 6, that's enough. Why? And sometimes it's just custom. But asking those questions between people can be very good. So you don't need to have your dean necessarily if you've got some dean. You don't need to have a colleague who's a senior person in your department if you have a colleague who's in another department who wants to participate.
Sorry, I've noticed in ICMGE.
Yes.
Over the
But the physicists don't follow that.
That's what I'm asking. That's my question. They
No,
are
those-
writing that for medics. It's very common that head of department, seniors will be on the paper.
So they be on the paper, that's fine, as long as they do some work.
Yeah,
It's
they
not just on
they
there.
haven't contributed as they are saying that.
So why do we write down
Substantial.
rules? We write down rules because people don't know how to follow them if they're not written down. So they'll be written down, and people will read them, and then they'll argue with them, and then eventually, maybe in another 5 or 6 years, or 7 or 8 or
I
9.
mean, because they have got 4 points to be on the paper.
Mhm.
Okay, but finally they say that seniors, head of department, medics is very acceptable that
Yeah, it is.
They can be included.
It is. They need to be able to say why
Well, yes,
in a
that's
way
the
that we can all agree with, or that everyone in that environment knows, so that you don't look at the list and say, well, that one is in the 16th spot. We know he didn't do anything. He's too far down. Maybe he gave samples. But it is to understand, the purpose of authorship criteria is so that everybody knows what happened. And the physicists know what that 432nd person did somehow. You know, if you have 500 authors, I can't tell why they're all authors, but they know. And that's their cultural way. But asking about that compared to medicine or compared to biology or compared to genetics is a very good topic for discussion. And often it points out that we don't know why we do things the way we do them. Because I can't,
Nobody can.
no. One of the other things that I think was important that we talked about multiple times yesterday, and I'm going to think about this now as we wrap up and move to the rest, is the challenge of time. You will always know more than you can teach. It may not feel that way when you're trying to prepare for class, but you can never tell your students everything you know. And that's very frustrating.
Comprehensive,
Well, and you hope that students, if you give them opportunities to learn things that interest them, that they'll go learn on their own as well. They're going to have to. Because science is moving so quickly that the things they learn in school today aren't going to be true in 5 years. The basic stuff will be true, but it won't be the complete story. And so students will have to learn how to keep up with what's happening in their field after they're not going to class anymore. So I would like to encourage you to think about encouraging your students to read outside literature. And I know it's hard in an environment where many journals are not available, but many journals are. The Public Library of Science, PLOS journals, have a lot of good articles on responsible science. And one way that I would recommend for teaching, which I've done, I'm not doing it in my current situation, but I've done it in the past, is to have a monthly journal club. That's what we call it. I don't know why it's club, but it just makes it sound more friendly. But a monthly or a quarterly event where you read an article, everybody reads the same article, and you kind of talk about it. PLOS One in particular, PLOS Med, there are a number of Public Library of Science articles that are open access journals, and they talk about all of the issues we've talked about. You can get your students to read it online, even on their phone, open access, and come talk about it.
Another question, I think we must discuss when we must begin to talk and to educate people about responsible science in school or in the university.
Personally, I think the first time you take a science course, 8, 9,
Yeah.
10,
I know.
it's important to understand scientists are looking for the truth, so they always tell the truth. Scientists know they can't know everything, so they always talk to each other and ask each other, what do you see? Scientists know that they have short memories, so they write everything down. Scientists know that you're never always right. That's backwards, but that you can't always be right. So you ask questions all the time. Is that right? Is that right? And maybe you won't know right away that it's right or not. You can teach that to a 9-year-old and a 10-year-old, and then as they learn more about peer review and about keeping records and about objectivity and self-criticism, then they can build on that to understand the more sophisticated professional things we talk about. Not just, how do I get the right answer? Because that, unfortunately, people who are always dedicated to getting the right answer are more likely to cheat, to do well on the exam, to get into medical school. Oh my goodness, what do they do when they get there? They cheat. So, having conversations, not just courses, like the active learning, I think that the journal club is an easy way to find more time. Deans don't object. You're reading the literature. Students are interested because it's something that just got published. Your colleagues may be interested. There have been a number of good articles about publication, where the publications really illustrate how uncertain some of the literature really is. And Retraction Watch is something I want to show you when we take the break. There is a blog that is open access called Retraction Watch. I get it on my phone, announcements 2-3 times a day. This journal just pulled this paper. This author just said, yes, we made up those data. And it's worldwide, looking at the problems of the integrity of science and authorship questions and retraction. And it's fascinating to look at, and you can give students that address and say, we're going to talk about Retraction Watch today. Another thing to get that's free. So I'm going to stop so that we can talk about assessment and how you did the assessments. But you will be getting emails, I think soon, with the information about the textbooks that you received, the global science book, translated into Arabic, that will be available for free to download as a PDF, that is intended to be used as a textbook for people, students around the world. And it should be something that you can find as a good resource It's not the sort of textbook that you memorize. It's supposed to be one that helps discussion. But that, along with the Blue Book from the Inter-Academy Partnership, will be both in Arabic and in the original English. And so you can talk about that. Look about the translation. Did the translation into Arabic say what you think it needs to say? Some things you can't say in Arabic that you can say in English and vice versa. And I'm not sure what nationality the person was who was writing in Arabic. Do you know, Lita, the translators? Are they? No. So to think about that,
Sometimes it doesn't.
it does sometimes make a difference. As you can see with the way Alistair and I talk about the same things with different words. We are going to talk now, got it?
No. Yes.
There you are. Yeah, good. I was very impressed, as I turn it over to Lita, how many of you did very comprehensive assessments at the end, the summative assessments, not as exams, but to evaluate what change in attitude and knowledge your trainees had had, the participants in your program. I think that that's a very good start on a knowledge base for you about how to plan your next courses or your next activities. It's something that we often don't do enough of. They're dividing us up into groups. We don't do enough of it, but at the same time, it helps the teacher determine what to teach next and helps you be self-critical and think about how to plan for your next steps. So we're going to talk about our own assessment of this program and some of the things that we have learned out of this program ourselves, and then a little more about assessment for the longer term. So Dr. Anestia?
Yeah, thank you. Okay, so